Next, we're going to take a look at graphing lines in slope-intercept form. First thing we need to do is define what is slope-intercept form of a line. That form is y equals mx plus b. In this equation, the m is the slope. We've seen that before. M always represents a slope. And the b is the y-intercept. Remember, an intercept is the point where the graph of the equation, or the graph of the function, crosses the axis, in this case the y-axis. The x and the y are just the variables of the equation, so those are going to be the variables. So we're going to jump right into an example. So here we have graph the equation y equals 2/3 x minus 1. So the first thing we want to do is just pick out what are the slope and the y-intercept. The slope, remember, is whatever is attached to the x. In this case, that would be the 2/3. And the y-intercept is whatever is not attached to the x. So the -1. It is going to be important that we pay attention to the position of the objects with relation to the x, not strictly which one comes first. It could be that the equation is presented to us in a form that's not actually in this y equals mx plus b form. It might be a little bit out of order. We might have to solve it for y, or we might have to recognize that, hey, these things are written backwards, not a problem. We just need to make sure we choose the m to be the thing attached to the x. The b is whatever is by itself. We are always going to start by plotting the y-intercept. That is the only point that we know from this equation. The slope gives us a motion from one point to another. So we have to start at the y-intercept, the y-intercept being -1. So I place that on the y-axis as a black dot. The slope, remember what the slope is. The slope is the change in y over the change in x. Or another way to think about that, change in y. If we think about that graphically, what does the change in y represent? That means we're going up and down. You can think of that as the rise. If we think about the change in the x variable, that's how much we're moving side to side, or what is often said to be the run. So you may hear slope referred to as rise over run. So from our slope, we can see that we need to rise by 2 and run by 3. From our y-intercept of -2, we're going to go up by 2. 0, 1. We've risen by 2, and now we're going to run by 3, or go to the right by 3. 1, 2, 3. And so our point will be at 3, 1. Those will be 2 points along our line. We would have infinitely many points. We could do this all day long, but all I need to do is have 2 points. I'm going to do my best to draw a straight line through those points, and there will be the graph of my equation. Let's go to another example. Let's graph the equation y equals -2x plus 3. I start off the same way. I'm going to pick out my slope. What's attached to the x? That's the -2. My y-intercept, what's by itself? That would be the 3. Just like before, I'm always going to plot the y-intercept first. So I'm going to go up to 1, 2, 3 on the y-axis. And then the slope tells me how to move to my next point. So my slope is -2. That seems like a problem because we just said slope should be rise over run. I don't see any denominator number here. But remember that any whole number is always over 1. So we can think of -2 as -2 over 1. So that tells me from my y-intercept of 3 to go down by 2. 1, 2 takes me to 1. And then I'm going to go to the right by 1. So it gives me the point 1, 1. I'll connect my dots on a straight line, and there would be my graph. Now, I did that a little bit hurriedly. I said we go down by 2 and then I go to the right by 1. How do I know it's supposed to be a right by 1? Why didn't I, instead of going down to right 1, why didn't I go to the left 1? It was a negative after all. Well, keep in mind how I have it written here. Just the -2 is negative. The 1 is a positive, indicating that we should go to the right, that we're going a positive direction. Could we also have written this as a 2 over a -1? Sure, 2 divided by -1 is still -2. That would tell me I need to go 2 in the positive direction on the y-axis, or up 2, 1 in the negative direction on the y-axis, or left 1. So if I go up 1, 2, and then to the left by 1, other than the fact my graph is not perfectly straight, my line is not perfectly straight, notice we should get the same line. It's a little bit wavy, but it doesn't matter if I go down to right 1 or if I go up to left 1, we have that same straight line. Could I have gone -2 over -1? Well, no, I can't, because what is a negative over a negative? That is a positive. That is not the same thing as a -2. So when we have these negative slopes, we have to remember we need to go in negative direction just one time. So if we go down, we have to go to the right. If we go left, we have to go up. Down is negative, up is positive, right is positive, left is negative. Let me compare that to what I did just a second ago. Here we had a positive 2/3. I went up by 2 and to the right by 3. That is equivalent to if I had actually gone a -2 over a -3. That is still a positive slope. So I could have gone down 1, 2, and to the left by 1, 2, 3. And notice I'm going through that same point right here. So we do have that same point. Not to confuse the point of seeing all these positives and negatives, the key though is if we have a positive slope, we want to go the same direction. So both positives or both negatives. If we have that negative slope, we've got to split that. We've got to go positive one direction, negative on the other. Let's take a third example. Here we have the graph y equals 1/3 x. Our slope would be equal to 1/3 because that's attached to the x. And then we go looking for the y-intercept, and I just don't see any other numbers. Is that a problem? Well, no. Keep in mind if we don't see anything there, that just means there is a +0. We wouldn't write a +0, but that's what it means if there's nothing there. So that means our y-intercept must be 0. So we're going to start at our origin, point 0, 0. The slope tells me to go up by 1 and to the right 1, 2, 3. And there would be my line. Let's do one final example. Let's graph the equation x plus 2y equals 4. Now if we look at this, this isn't actually in slope-intercept form. This is not in that y equals format that we would like. So we're actually going to have to start by taking this equation and rearranging it to solve for that y. So what would be my first step in solving for y? I need to subtract the x from both sides. When I do that, I get 2y equals 4 minus x. Next thing I'm going to need to do, I'm going to need to divide by 2. I have to divide this entire right side by 2. There's two terms over there, so what we're doing is we're actually taking both of the terms and dividing by 2. We're taking every single term, every single piece, and dividing it by 2. When we do that, 2 divided by 2 gives me just a 1y. 4 divided by 2 is 2. And then we have an x over 2. So we finally have the y solved for. Y equals 2 minus x over 2. Now there's a couple things that look funny in this. One, it's not perfectly in that slope-intercept form. Remember, slope-intercept form should be y equals mx plus b, not b minus plus x. If it makes you feel better, you can rearrange this to put the x term first. Negative x over 2 plus 2. I've just moved the x over 2 to the front term and the plus 2 to the back. I do have to remember that the negative was on the x term, the 2 was positive, so we need to keep the signs correct. So we can rearrange it if we want to. You don't have to. You can recognize that the b is going to be the 2 in either format because it's what's by itself, and then the x contains the m. Now the other thing that might look a little bit funny to you is that we have an x over 2. We don't have a coefficient on the x. And remember, a way we can rewrite that x over 2, we could rewrite this as y equals 2 minus 1/2 x. It is the same expression. We have a coefficient of 1/2 on that x. X over 2, that's a 1x over 2 or a 1/2 x. So there's several different ways we could write this equation. It doesn't matter. What we want to be able to do is pick out our slope and our y-intercept. So our slope is going to be the negative 1/2. Doesn't matter if it's in this format, or this format. If we look at what's attached to the x, it's a negative 1 over 2, a negative 1 over 2, or a negative 1/2. Then our y-intercept, whatever is by itself, that would be the 2. The 2 here, here, and here. So now we have everything we need to graph this thing. I'm going to start off at my y-intercept at 2. From there, I have a negative slope. So I have two options. I can go down 1 and to the right by 2. Or I could have gone up by 1 and gone to the left by 2. That idea of moving in opposite directions. If I move a positive on the y, I move a negative on the x. Up and left, or I move a negative on the y and a positive on the x. And so when I graph my equation, there it is. The slope is often misused, especially with those negatives, because we try to use too many negatives. We go down and left, something like that. So a good kind of way to look at it and to make sure we have the right slope, negative slope should always be going downhill. If we look from left to right, they should be going down. Positive slopes will always be going up. So if I look at these four graphs really quickly, just at their general pictures, here we had a positive slope going uphill, negative slope going downhill, positive slope up, negative slope down. That gives us a really quick estimate if we have found that, or if we've graphed that the correct way, have we at least gotten it going in the right direction.